Next we have to study concept of Caroli's force. So what is that Caroli's force? Caroli's force is a fictitious force acting on a particle in a rotating frame of reference. If a frame of reference is in motion, then Caroli in rotatory motion, then Caroli's force act. This Caroli force is given by, this is F is equal to minus 2m. We know that this is omega into V. So where omega is the angular velocity of a rotating frame of reference, V is the linear velocity of the particle in that frame of reference. So Caroli force is a fictitious force acting on a particle in the rotating frame of reference. It is given by F is equal to, so this is C, F is equal to minus 2m omega into V. You know that omega is a vector angular velocity, V is linear, that is also vector. It is a cross product of two vectors. Therefore, the magnitude of this Caroli's force is 2m omega V into sin theta. P cross Q is equal to PQ sin theta. Omega cross Q is omega V sin theta. The magnitude of Caroli's force depends on omega V and theta. What is that theta? Theta is the angle between these two vectors. Angle between omega and V. See this Caroli's force is 0 if omega is 0. If omega is 0 means what? If a frame of reference is not rotating. If the frame of reference has got linear motion, then also omega is 0. Then if V is 0, V is 0 means if the particle is at rest, then the CF becomes 0. And theta, if theta is 0, means omega and V are parallel, then this Caroli force is 0. And when it is maximum, if theta is 90 degree, then Caroli's force is maximum. Means if omega and V are perpendicular, then Caroli's force is maximum. Then what is the direction of this Caroli's force? The direction of the Caroli's force is perpendicular to V and omega in this direction. So this direction is judged by this opposite to the right hand screw rule. Opposite to the right hand screw rule means if this is V and omega, if if you are rotating this, because P and omega are changing in this direction, if you are rotating in this direction, actually force should act in this direction, left side. But due to this negative sign, this force acts opposite to that judged by left hand screw. So the direction of Caroli's force is opposite to the direction given by the right hand screw rule. So because of this condition, assume that Earth is rotating with constant angular velocity omega about this axis, and it is north and it is known as south. Upper part is called as northern hemisphere, lower part is called as southern hemisphere. That means in the figure it is. So if always assume this is east and this one is west. Earth rotates from west to east. Omega is in this direction. So, according to the right hand screw rule, if a particle is moving in the northern hemisphere, it deflects towards the right. And if you observe from the southern hemisphere, the direction of omega is opposite to that. Therefore, if a particle is moving horizontally in the southern hemisphere, it deflects towards the left because of this opposite way of considering the right hand screw rule. So what is this? They may ask, what is this Caroli force? Caroli force is a fictitious force acting on a particle in the rotating frame of reference. It is given by minus 2m omega into v. Then magnitude of this is 2m omega v sin theta. And definitely f depends on omega and v. If a frame of reference is not rotating, f is 0. If particle is at rest, again this f is 0. If omega and v are parallel, f is 0. But f is maximum. Caroli's force is maximum if omega and v are perpendicular. Then what is the direction of the force acting on this? It is perpendicular to the plane containing this omega and v. And that direction is opposite to the direction given by right hand screw rule. Because of this Caroli's force, in the northern hemisphere, when Earth is rotating from west to east, the particle moving in the northern hemisphere deflects towards the right, because force acts towards the right because of the negative sign. And omega is in one direction, but in the southern hemisphere omega is in the opposite direction, direction changes. Therefore, if a particle is moving in the southern hemisphere, it deflects towards left. Next you have to study component of Caroli's force acting on a particle due to rotation of the earth. We know that Earth is rotating constantly about its axis. So if omega is the angular velocity of the Earth, So all particles which are lying on the surface of the earth also move with the same angular velocity. If it is the case, if a particle P is placed on the surface of the earth, what are the different forces component of Caroli's force acting on a particle? That we have to calculate. See, earth rotates from west to east. Let P be the position of the particle, and you know that according to the right hand rule, this is the direction of omega. So let this x, y, z be the axis rigidly fixed to the particle. So this is your x-axis pointing towards east, and this one is y-axis, and z is radially outward, vertically outward. So we have fixed this x, y, z rigidly to a particle P, coordinate axis. So x, this is y, and this one is z. Of course, the unit vectors along x, y, z is I, z, and k. Then this omega is divided into two components. If lambda is the co-latitude, lambda is the co-latitude, and the latitude at point P is this angle. Latitude at point P is 90 minus lambda. If lambda is the co-latitude, then the latitude at point P is 90 minus lambda. Then this omega can be resolved into two components. You know that if this is R along horizontal direction, if this is your angle theta, it is R cos theta. Similarly, this side, this is what? Your R sin theta. Similarly, this omega, if this is your lambda instead of theta, along this is omega cos lambda, definitely it is along z axis. Then this is omega sin lambda is along y axis. So therefore, you know that your omega is equal to, so I will write this is omega I plus omega k j plus omega k. With this I, there is no angular velocity along x-axis, I-axis. This omega has got only two components. One is along z, another one is along y. Therefore, this is omega is equal to, so this is 0 plus, what is this j component? So this is around y-axis, it is j. Omega sine alpha. Sine lambda plus. Then what is around this z-axis? Omega cos lambda. This is omega cos lambda. This is what total angular velocity of the particle. Let V be the velocity of the particle. So this particle P is in the xy plane according to the right hand rule. So particle P is in the xy plane but not in the z plane. So velocity along z axis is 0. Therefore total velocity is equal to, see, this is Vxi Vyj plus 0. Why it is 0? Because there is no velocity component along z-axis. You know that Caroli's force is given by this F is equal to minus 2m omega into V is the Caroli's force. So you know that it is a cross product of omega and P, or this is minus, write this as, this is equal to minus 2m in the form of determinant. So x component omega is 0, y component is omega sine lambda, then z component is omega cos lambda. Of course, this is your I, J, and this one is K. And the velocity is Vx, and this is Vy, and this one is 0. And let us simplify this. This is minus 2m inside the bracket. So what I, this is given, product of this minus product of this, correct? This is 0 minus omega Vy cos lambda. The sign in the determinant is, I think this is plus, this is plus, and this is also plus, and these are minus. Now this is minus z. Now product of these two, it is 0 minus these two, omega Vx it is cos theta, these two, and similarly plus p into what? So product of these two, 0 minus omega Vx into sin lambda. So you can do this bracket. All this is, it is minus of minus is plus. It is 2m omega Vy cos lambda. Of course, into this is I plus or minus it is. See, this is minus into minus is plus, but this is minus. What means here? Minus inside the bracket. What? 2m omega Vx cos lambda. Of course, this is z. Then this is minus into this minus is plus. It is 2m omega Vx sin lambda. Of course, this is k. Now I have got the three component of the force. This is Caroli's force, total force. So this is what x component, this is what y component, and this one is z component. Because of these coefficients, unit vectors I, j, k. You know that I, j, k are the unit vectors. Write down these components. Of course, the three components are, it is f xc, x component. What it is? It is 2m omega Vy cos lambda. Then I got another one, fyc. fyc. That means y component, we are discussing about the components. fyc is minus 2m omega Vx cos lambda. And what? Another one. So fzc is equal to, so that one, it is 2m omega Vx into what? It is sin lambda. You write down this. Next we have to calculate what is the magnitude of these Caroli's forces. So what I have done so far is, because you know that it is minus 2m omega into V. We have calculated what are the different parts of omega and also different parts along xyz V. We have used the determinant and we got these components. So what are the total force? Magnitude means what is the total force acting on this particle. So magnitude of this corrosive force is given by, it is square root of these three components. Square of these three components means it is f x c square plus f y c square plus f z c square. Substitute these values. We are calculating the magnitudes. So it is a square root of, okay, your fx is, it is 2m omega Vy cos lambda whole square. Then plus inside the bracket it is 2m minus 2m yc omega Vx cos lambda whole square. Of course this square root extends. Then plus what? Square of this third term. It is 2m omega Vx sin lambda, its square. See, if you take the square of this, it becomes 4m square omega square. Follow it carefully because I want to write directly. 4m square omega square. Here also, of course, this becomes plus because of that square. 4m square omega square. 4m square omega square. What is the square root of 4? 4 is 2. M square is m. Omega square is omega. The square root, taking those quantity outside, 2m omega inside the bracket Vy square cos square lambda. Of course, into this square. Then plus Vx square, it is cos square lambda. Then plus Vx square sin square lambda. Square root it is, write 1 by 2, is to 1 by 2. Okay. To m omega. See here. It is square cos square lambda, Vx square sin square lambda. Take Vx square outside. Cos square theta plus sin square theta is equal to 1. Therefore, this magnitude of the force is Vy square cos square lambda plus what remains there? X remains. Vx square. Of course, this is a square root. So this is your magnitude of the counterweight force. Then you have to calculate what are the x component of the force. What are the horizontal component of the force and what are the vertical component of the force. So the forces which are lying in the plane, they are horizontal, in the plane of the point P. So a force which is perpendicular to that, it is a vertical component. One is horizontal. Horizontal component, they are the two forces lying in the xy plane. Vertical is lying in the z plane, along the z axis. Now what are horizontal components? The forces which are lying in the xy plane, they are called as horizontal component. So, magnitude of the horizontal component. This is C. Sorry, this is F H O R C means magnitude of the horizontal component. Only we have to take the square root of these two. So this is equal to square root of f x c square plus f y c square, or this is square root of, it is 2m omega Vy cos lambda, this is whole square, plus another one is minus 2m omega Vx into this is cos lambda, it's whole square. Then what you can take outside? 2m omega can be taken outside. This is 2m omega is taken outside. What is there inside the bracket? It is Vy square cos square lambda plus Vx square cos square lambda. Of course, it is a square root. So, of course, we call this equation as A, this equation as B. You have to remember these equations. So, magnitude of horizontal component is 2m omega Vy square cos square lambda plus Vx square cos square lambda is to half. What are the components? So, the component are FHORC. You have to write I component and J component. Because it is horizontal, it is 2m omega Vy cos lambda into I. So plus, sorry, it is not plus, now it is minus. It is minus 2m omega Vx cos lambda, this is G. These are the components of the horizontal component. So from this, it is clear that, which one? This one. Magnitude of the horizontal force is maximum when this lambda is 0. Because if this lambda is 0, cos 0 is 1, it is a maximum. And where it is, lambda is 0 means at the poles. Ille ಯಾವ component just maximum for a horizontal component, because lambda decreases here. Then it is minimum when lambda is 90 degree. If lambda is 90, yes, if lambda is your 90 degree, what happens? Cos 90 is 0, entire thing becomes 0. Means where it is 90 is at the equator. So lambda is 90 agatre, cos 90 is 0, entire term is 0. You have to remember this. Magnitude of horizontal component is 0 at the equator, but it is maximum at the poles. Then what about vertical component? So FVERC, vertical component ಅಂದಾಗ ಯಾವುದು ಈಗ z axis. It is 2m omega Vx sin lambda into what? K is vertical component. Then tell me when this equation is maximum. Once again it depends upon lambda. If lambda is 0, if lambda is 0, and of course vertical component is 0, isn't it? Because sin 0 is 0, this becomes 0. For what angle? For lambda is equal to 0. And lambda is equal to 90, what happens here? What is the sin 90? Sin 90 is 1. So this is sin 90. That has got a maximum value. Vertical component is maximum at the equator, minimum at the poles. So this completes your theoretical part of frames of reference. See the examination, they won't ask this derivation. ಇದೆಲ್ಲ ಡಿರೈವ್ ಮಾಡಿದ್ದೇವೆ ನಾವು, ಅದನ್ನೇನು ಕೇಳೋದಿಲ್ಲ ಎಕ್ಸಾಮ್. ಬಟ್ ದ ಥಿಂಗ್ ಇಸ್, you have to remember this one, and this, and this one. solve some examples. So with reference to the rotation of the earth, they will ask some examples in the examination. Now even direct ಕೊಟ್ಟಿದ್ವಿ ಅಂತಂದ್ರೆ ಲ್ಯಾಂಬ್ಡಾ ಏನು ವಿವೈ ಏನು ಅನ್ನೋದು ಗೊತ್ತಾಗ್ತಿಲ್ಲ. Because of that I have derived entire things. So component of Coriolis force ಹೆಂಗೆ ಬಂದು ಅನ್ನೋದು ನಿಮಗೆ ಗೊತ್ತಾದರೆ ಇವನ್ನ ನೀವು ನೆನಪಿಟ್ಕೊಂಡು ಸಾಕು. So ಏನು ನೆನಪಿಡಬೇಕು, horizontal component is given by this, vertical component is given by this, magnitude is given by this. So like this you have to remember this.